BC Calculus, 7.2 Antidifferentiation by Substitution, Part 2. This is actually the second video of my antidifferentiation by parts. So we did all this before, and I talked about that we can do this repeatedly, like x squared is going to become 2 of the x, then eventually 0 as we crank down. So there's a cool little tabular form. You pick an f of x. In this case, we'll say f of x equals x squared, and you make a list of it and its derivatives. And you pick a g of x, in this case e to the x, and you go g of x and its integrals. And so you are taking the derivatives of x squared, which is 2x, then 2, and then 0, and e to the x makes life easy. E to the x, e to the x, e to the x. And then you use this little tic-tac-toe technique. And this is going to be positive, this is going to be negative, this is going to be positive. And when we're done, you just write it out. The answer is x squared e to the x, that's the first one, minus 2x e to the x, that's the second one, plus 2e to the x plus c. And it's called tabular integration, and it's a pretty neat little technique to save yourself some time and aggravation. You'll see my answer key. I've actually written it out in certain places to my set of problems, and it takes forever to do it otherwise. So just, if I were you, I'd pause the recording and see if you can do it yourself, because I'm going to go right ahead and do it. And integral is a little bit trickier. Integral of sine of x is negative cosine of x. Integral of negative cosine of x is negative sine of x. Cosine of x, sine of x. And we go positive, negative, positive, negative. So integral of, try and fit it all in here, x to the third sine of x dx is negative x to the third cosine of x plus, because the negatives cancel, 3x squared sine of x plus 6x cosine of x, can't quite fit it all in, minus 6 sine of x plus c. Just checking my work. Yeah, I got it, I think. Looks good. So that's called tabular integration. It's a pretty cool little technique. Save some time and aggravation. Integration by parts can be used for almost anything. Sometimes it makes it easier. So you look at this, you're like, well, it's just ln of x. And then you actually stop, think, and say, well, I don't really know what I'm doing here. So let me try u equals ln of x. A lot of people say, well, how'd you know to make the u value ln of x? So because I get a nice easy derivative. I don't have a nice easy integral. If I had a nice easy integral, I would have gone with it. dv equals dx and v equals x. In which case people say, whoa, 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 I thought the whole purpose of anti-differentiation by parts was to get rid of stuff. You've just brought in an x. And I say, well, yeah, let's see what happens. Integral of ln of x dx equals x ln of x minus, which I keep forgetting, x over x dx. X ln of x minus 1. The integral of 1 is just x plus c. So some neat stuff, and then some really neat stuff here. We've got arcsine, and the problem is to find the integral of arcsine, and we have to deal with the point. We'll deal with that later. You know what? I always write it as arcsine. I don't like writing sine to the negative first for obvious reasons. And okay, we'll use parts. U equals arc sine x, du equals 1 over, I'll just put the dx on top, square root of 1 minus x squared, and dv equals dx, and again we're bringing in an x, which is good because that'll be the chain rule inside. So we get x arc sine of x minus the integral of x dx over 1 minus x squared. How about we practice our substitution? U equals 1 minus x squared du equals negative 2x. Du over negative 2 equals x. Pardon me, dx. So we get x arc sine of x minus the integral of, I'm going to put it out front, 1 over negative 2. These will cancel. Of du over square root of u, which is an integral I can do fairly quickly. X arc sine of x plus, I'm going to do it over here in a little box off to the side, u to the negative 1/2 integral du is add 1, u to the 1/2, divide by 1/2. In other words, just love that for 1/2 times 2u to the 1/2 plus c. And we got to do some substitution, x and some canceling. X arc sine of x plus square root, which is just u to the 1/2, 1 minus x squared plus c. And forgive me for saying, but that's some pretty slick math, so I think it's cool. That is it. Happy mathing.